On this video, I want to check this two-way coaxial switch, particularly this made by Daiwa, which I believe to be the best of those three. And the configuration I want to check is this one. I am simulating that the that we've got two radios connected to these two ports. Let's call it radio A and radio B. This port is going to an antenna. So basically we've got a common antenna. Then we switch over one radio or the other. So what we want to check is that at the moment we transmit with a 100 watts radio through the coaxial switch to the antenna. I want to check the isolation between these two ports. So on this port I will be receiving what's the leakage that comes through and back here. So we check the isolation in dB and we see if that's good enough to withstand a 100 watt signal without damaging the radio B, the front end of the radio B. Okay, the setup is a minus 10 dBm signal level coming out from port N, going into the coax switch, and the incoming signal from the coaxial switch, which is connected to this port, will simulate the radio B and what it receives when I transmit. So let's center on the screen there, and let's connect all the cables. We go on spectrum analyzer. We are at 25. I'm looking for something to point. We are at 25 megahertz center frequency. Span is 5 megs per division. We've got 10 divisions, so the span is 50 megs. So basically from 0 to 50. Okay, we want to look at the HF plus 6 meters. Okay, because this coaxial switch, I believe, I'm not sure actually, but I believe they're designed for HF mainly. So yeah, let's switch on the tracking gen, and we see we have got two markers. Marker number 1, which is the one active now, is at 1.8 megs, 160 meters band, and I have a level of minus 93 dBm, more or less. To this we have to subtract the minus 10 dBm level which comes out from the generator, so the difference between the two signals is 83 dB. So let's annotate that 1.8 max is 83 dB. Second marker is at 10 meter band, but as you can see it's pretty flat. Let's actually change, that's fine, sensitivity to, we're putting some attenuation there. Let's go to, yeah, let's go there. So marker number 2 is at 28.5, and we read minus 88 dBm. minus 10, which is minus 88 plus 10, it's minus 78 dB of attenuation, okay? At 28.5 max, 78 dB of attenuation. So what does that mean? Well, let's take a look. With the help of this table, we can now calculate what what it means for the radio B to to have a signal which is 78 dB lower than 100 watts on 10 meter band. So we start from 100 watts and we subtract 78 dB and we end up to, this will be minus 50, minus 60, minus 70, so minus 78. Okay, so we will end up here. What does it mean? It means that we will see, the radio B will see a signal which is S9 plus 45 dB. S9 plus 45 dB. Because minus 13 usually is S9 plus 60, that's full scale. Minus 23 is 10 dB less, so 9 plus 50. Minus 33 is 20 dB less, so S9 plus 40 dB. So we end up here, which is 5 higher. So radio B will read S9 plus 45 on 10 meter band. And if we go on 160, we measured another 5 dB of attenuation. So we will instead read exactly 83, yeah, minus 33. So S9 plus 30, S9 plus 30 dB. So in fact I can confirm what I'm saying because I have already used the switch with my two radios, the FT1000 on one side and the FT991 on the other side, and yeah, it is what I was reading, in fact. So that's all for this video. I have also checked the other two switch, this one here and this one here. I've got these two, which are similar, but actually this one is a bit better for some reason. And yeah, I have put a label, so I put A/B isolation on the whole HF spectrum is more than 70 dB, and on the Daiwa I put A/B isolation on 50 megs is more than 80 dB. So for me it means that below 50 megs it just gets better. Okay, and I don't want to use this higher than 50 megs, honestly, because of the also because of the SO239 connectors. Even though I have been checking this on UHF on 430 megahertz, 70 centimeter band, and the isolation was still not bad, I would say. It was around 46 dB, if I'm not wrong, about 46 dB. Well, that's all for this video. Thanks for watching. I hope that's been helpful. again, as always, to somebody watching the video. All the best, 7-3.